Hello everyone, welcome to my channel. In this video, we shall show a very important statement based on the properties of circle. That is, if AD is the diameter of the circle, center of the circle is at O, and AB parallel to CD in the following figure. AB parallel to CD, okay? Then we have to show that AB equal to CD. So it is given AD is the diameter of the circle, center of the circle is at O, AB parallel to CD means AB and CD are two chords which are parallel to each other in figure. We have to show that the chords are of equal length. So let's first note down the given condition. So here given, first of all, AD is the diameter, O is the center, AB and CD are two chords where AB parallel to CD. Required to show AB equal to CD. So again, for proving that AB equal to CD, we have to use the properties of circle. Now we know that if we want to show that two different chords of a circle are equal in measurement, then in many cases, in most of the cases, we have to show that they are equidistant from the center, because by the properties of circle we know that equal chords are equidistant from the center. So here also we have to prove the equality between these two chords. So we will show it by proving that these two chords are equidistant from the center. Okay, so that's why we have to make a construction here. Let's consider a perpendicular on the chord AB. Suppose the name of the perpendicular here is OP, and another perpendicular OQ on the chord CD, right? So these two perpendiculars will actually give us two distances. The distances of chord AB from the center and the distance of the chord CD from the center also. So now by logical steps, if we can show that the measurement of these two segments OP and OQ are equal, then it will be proved that these chords are equidistant from the center. So from that we can make the conclusion that the chords are of equal length. So let's try to prove it. First we have to mention this construction. Two perpendiculars OP and OQ are drawn on AB and CD respectively from the center O. From the center O. Okay. Now let's start to prove the statement. Look, if we consider triangle OPA and triangle OQD, these two triangles, then let's see what do we get here. First of all, this angle equals to this angle. By construction, they are 90 degree in measurement. Secondly, this CD is parallel to AB and AD is the diameter. So it is the transversal, right? So of course these two angles will be equal as AB is parallel to CD and they are alternate interior angles. So this angle equals to this angle as they are alternate interior angles, because AB parallel to CD, it is given already in the question, and AD is the transversal. This diameter is playing the role of a transversal, right? So this angle equals to this angle. Moreover, AD is the diameter, O is the center. So OD equals to OA. So by angle side property, we can say that these two triangles are congruent. So as they are congruent, we may conclude that OP equals to OQ, and hence the statement will be proved. So let's do this. From triangle OPA and triangle OQD, we get angle OPA equals to angle OQD, both 90 degree by construction. Okay, OPA equals to OQD. Secondly, CD AB parallel to CD and AD transversal. AD is the transversal. So as I have already told you that angle OAP equals to angle ODQ. Angle OAP equals to angle ODQ. They are alternate interior angles. Because we know that if two lines are parallel and a transversal cuts them at two distinct points, then the angles formed in this position, that is in the alternate position of the transversal, are called alternate interior angles, and as the lines are parallel to each other, so they will be equal. That means if the lines are not parallel, then also this alternate interior angles will be formed, but they will be equal, but they will not be equal in that case. Okay, they will be equal in only in that case when the line segments are parallel, the straight lines are parallel to each other. I repeat, if two lines are parallel and a transversal cuts them at two distinct points, then in the alternate position, in the alternate sides of the transversal, the angles are formed which are called alternate interior angles. And if the lines are parallel, they will be equal. If the lines are not parallel and the transversal cuts them yet, then also these angles will be formed, but they will not be equal in that case. But here the lines were parallel, it was given in the question. So obviously as the lines are parallel, we can say the alternate interior angles are equal. Got it? Thirdly, OA equals to OD. Why? Because AD is the diameter and O is the center. So OA and OD are the radii of the same circle. So they are equal. So we can say triangle OPA congruent to triangle OQD by which condition? Yes, angle side condition. So again the same thing, that is as I have already explained. So OP, because OPA triangle is taken first. So OP equals to OQ, CPCT, corresponding parts of congruent triangles. Here OP and OQ are the distances of the chords from center, and they are equal, and OP equals to OQ. So they are distances and they are equal. So by this condition, by this statement or information, we can say AB equals to CD, as equal chords are equidistant from the center of a circle. Equal chords of a circle are equidistant from the center of the circle, and hence the statement is proved. Hope the explanation is clear to all of you.